Hello friends, this video on aldehyde ketones carboxylic acid part 35 is brought to you by examfear.com. No more fear from exam. Let's talk about some of the derivatives of carboxylic acids. We'll talk about acid chlorides, acid anhydride, esters, acids amide. Actually, we have studied all these actually, but we'll just do a recap of these because they are all acid derivatives of carboxylic acids. Let's start with acid chlorides. So what are acid chlorides? They are nothing but RCOCl form, correct? And we've discussed this, how to form this. You have taken RCOH, this, and this you react with PCl5 or PCl3 or SOCl2, you get RCOCl. The reactions we have discussed in the carboxylic acid reactions, you can see that. Also we have discussed the mechanism, and the boiling point of acid chloride is lower than corresponding carboxylic acid. It's lower than corresponding . Any guess why? It is because of hydrogen bond. See, this guy has more hydrogen bond. Hydrogen bond is not there, so it is the boiling point is lower for the acid chlorides. Now we'll talk about acid anhydride. So this is of this form. This also we have discussed, actually we have discussed the production of acid anhydride of this form. This is nothing but the condensation product of carboxylic acid, right? And to name this, you have to just replace the acid with anhydride. That's how you name it. For example, CH3COO, CH3, right? So if you see, this is ethanoic acid, right? From ethanoic acid, so it will be ethanoic anhydride. Ethanoic anhydride. This will be the IUPAC name. For common name, this is from acetic acid, so this will be acetic anhydride. Correct. So for example, this one, if I have two different in both sides, so in this case, if you want to write the what do you call IUPAC name, it will be, this is ethane, this is propane, so it will be ethanoic propanoic anhydride. So this will be ethanoic propanoic anhydride. Ethanoic for this, propanoic for this, anhydride. And why ethanoic comes first? Because A, B, C, D, E comes first, P comes later. It's ethanoic propanoic anhydride. That will be the IUPAC name of this, right? Similarly, if you want the common name, it will be acetic. This is acetic, and this is propionic. So it is acetic propionic anhydride, correct? This is how you give the name of anhydride. I explained the preparation of anhydride actually in the past few slides, where I have discussed that two carboxylic acids react and there is a loss of hydrogen or water molecule when they react in the presence of some acid. This is something which we have already done, so I will not spend much time on this, but I'll just write the reaction, just OR dash, it will give you RCOO R dash. So this water molecule will go out, correct? So it can also be prepared by actually the action of acid chloride on sodium salt of acid. So I have acid chloride and I have sodium salt of acid. So with that also, if we require, this NaCl comes out and this becomes this. This is why, because this is O minus and Na plus, this O minus will actually attack this guy, right? And this will be like this, and now this will again go back, again come back in this fashion, and Cl will be kicked out, and this you will get this compound. I'll not discuss this mechanisms too deep because it is not required for you now. But it's pretty easy mechanism. This O minus will attack this carbon. This will become O minus here, and then it will again come back, right? Because this is a lone pair. It come back, and chlorine comes out. You get this compound. And the boiling point, if you discuss, is more. Why more? Just guess. Why boiling point is more than the corresponding carboxylic acid? Why? Because the molecular mass is almost double, right? So because the molecular mass is almost double, is more, right? Because the molecular mass is almost double. So large molecular mass, large size means large van der Waals force. So the boiling point is more. The next is esters. So esters are of this form: R COO R dash, this form. So they are alkyl or aryl derivative of carboxylic acid. Right? So to name this, so I have carboxylic acid. You have to replace this IC acid with 8. That is how you name it. Replace this with 8, right? And you have to precede this by the name of alkyl or aryl group that replace the hydrogen of the acid. For example, I have this. So this is the one which is replacing. So I first write ethyl, and this is ethanoic acid. So instead of ethanoic acid, I write ethanoate. Correct? So you have to precede with the group which is replacing. So this is ethyl. So ethyl, and then instead of ethanoic acid, I write ethanoate. Take one more example. So here also, if you see, this is the guy who is replacing is ethyl. So it is ethyl, and this is methanoic acid. So it is methanoate. Correct? This is how you name this ester. And we have discussed the preparation of this. You take carboxylic acid, you react with alcohol or phenol. What you get is ester in presence of some acid. So I'll now discuss the mechanism once again. So in this case, it's an equilibrium reaction. The forward reaction will be called esterification, and the backward reaction will be called hydrolysis. Let me write one reaction to clear this concept. Right, this is my now carboxylic acid. This is my alcohol. In presence of H plus, it will form this and H2O. So this forward reaction is called esterification, and the backward reaction is called hydrolysis. So you can also prepare this instead of carboxylic acid. If you have acyl halide RCOCl, you can react this with alcohol, and then also you can prepare this. Here you will get HCl as the byproduct. So we talk about the physical properties. The lower esters are colorless and they have pleasant odor, right? The higher ones are colorful. They have some, no, they are also colorless, but they are solid. So the lower ones are liquid, the higher ones are solid. Correct? So the boiling point of esters are lower than the acid. The boiling points of ester are lower. Boiling point is lower. Why? Again, there is no hydrogen bond. If you see here, there is not significant increase in the mass. There is obviously increase. Instead of H I have R, but there is not much significant increase in the molecular mass, and the hydrogen bond is gone. So with that, the boiling point is lower than the corresponding carboxylic acid. Also, they are insoluble in water. Why? See, carboxylic acid were soluble little bit, but these are insoluble because there is no hydrogen bond. So they are insoluble in water. So just giving a high overview of all these things. The next one is the acid amides. So acid amides are of this form, RCONH2, right? This CONH2 is called amide group. So if you see the naming convention of this, example SCONH2, this is from formic acid or methanoic acid. This will be called methanamide, right? Or if you want to write the common name, it will become form amide. Example, if you take CH3CONH2, so it is from ethanoic acid, this will become ethanamide. Or if you want to give the common name, it will become from acetic acid, acetamide. Correct? Similarly, let's take this guy. This is from benzoic acid, this will become benzamide. So here the common name and the IUPAC name is exactly same. Preparation, we have already discussed this. This is from aminolysis of acid chlorides. We have discussed this. We take CH3COCl, we react with, or CH3COH also, react with NH3, you get CH3CONH2. Correct? Or we also get from the hydrolysis of nitrile. So for example R, we have triple bond N, you do hydrolysis, you get as RCONH2. This bond breaks, it get H, it get OH. Again it breaks, it get H, it get OH, right? So this OH, it forms O, RCONH2. So if we talk about properties, the first one, that is this guy, the ethanamide, is liquid. And all others are solid. Please note, the only first one is liquid, others are solid. Now they are little bit soluble in water because of the small hydrogen bond. Also the boiling point of amide is more than acid. Why? See, if you see the acid, this is little tricky. If you see the acid, they form dimers, right? So if you see the acids, they just form dimer. So there's only this, they all form lump like this, right? But if you see the amides, they form a bigger network. They form a bigger network actually. So if you see CH3NH2, something like this, they'll form a bigger network. So if you're forming a dimer, you're not that strong. But if you're forming a big network like a spider network, you are a strong person, right? Same thing here. It's forming a bigger network. It will form a bigger network like this. It will go on, big network. So it's a very big network, so the boiling point is high. In fact, this is the only exception. If you see in another case, the boiling point is generally lower than the carboxylic acid, but in case of amide, they form bigger chain of bonds, a large number of bonds. Thus, the boiling point is higher than the corresponding carboxylic acid. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.